Oh, it started.
There it is.
Good morning. Oh, Dee's got an intro song for you.
To introduce the area between two curves.
Yes.
Here we go.
It's coming.
This is right here.
Oh, weird.
He's on his way to school. Get it? He's on his way to school.
Yeah, no, I get it. Okay.
Okay.
I would rather not be reminded about being on wheels.
Proclaimers are awesome.
Is that a trigger for you now?
It is. Yes, very much so.
Proclaimers.
I sink into a deep depression.
With the Proclaimers?
No, about being on wheels.
Oh.
I'm ready to be walking again. I'm tired of this.
Just replace your legs. Yeah.
They tried. It's literally what I have going on. All the metal. Okay. We're going to find the area between two curves that don't touch. That's where we're going to start. And then we're going to start with, and then we're going to add in where they intersect. Yep. And then we'll even do when they're like different portions. So get a Kleenex.
I don't know. Actually, we didn't last time.
And this is 6.1. It does correlate to 6.1 in the book, by the way. Okay, so we have some two curves here, right? F and G. And if we want to find the area between them, now notice this is from A to B. So the interval is not the whole space between them. The interval cuts it off. You take the area under F minus the area under G, which makes sense, right? So you're finding this total area here. But then you have to subtract this portion that's not between them, which would be the area under F, or under G, sorry. Excuse me. Thank you. Gracias. Now, this is something that we had a little bit of a struggle with last year, was remembering when and how to subtract correctly when we were setting up the integrals. I remember this being a little bit of a struggle. So we're going to have to be careful with how we do this, okay? Okay, what do you mean by that?
Oh wait, what is it? Right. Which is on the top or bottom? A and B.
Right goes on top and left goes on bottom.
Which is where I left.
Oh, goodness gracious. So yes, it would be A to B.
Say left to right.
Is that how it? Is that's correct?
Yes.
I think he's about this.
Have I been doing that wrong?
I hope not.
No, I've been doing it right.
Okay.
Weird.
Okay, so we want to find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x, and x equals 0 and x equals 1. So I purposely did not put the graph on here.
Oh, so we have to know.
Uh-huh.
Will they be like that?
Yes. I would say most of the time you're given the functions. An exception to that might be a free response where you're doing this as part of something else. You might be given graphs. And then, but that you wouldn't be told to find the area between them necessarily. You would, it would be more along the lines of like the region is bounded by this on top and this on bottom, and it's being filled with water. You know, find the area, find the volume, whatever. And so then you would need to know that you need to find the area between the two. And then that would be more part of the revolving figure type dealio, which we'll get to. where it would be in 3 dimensions. So the first thing we need to know is which one is F and which one is G. Which one's on top and which one's on bottom. Yeah.
X squared plus 2 is on top.
How do you know that?
Because it's the parabola would normally be going up. The plus 2 raises it up.
Okay.
And also the negative x is going like that. So
Okay.
that one's always below the x-axis. This one's always above the x-axis.
Correct. And another way to think about the y-intercept. The y-intercept of the parabola is at 2, right? Which is at x equals 0, where they start. The y-intercept of the first one is at 2, and the other one would be at 0. So you know that this would be F, and this would be G. The reason that's important is because F has to stay on top of G, so we know which one to subtract. Okay, so it's important to delineate which is which. So we're going to take the integral of F minus the integral of G. Oops, negative x, sorry.
It's been a while since I stopped using
We always love a visit. What are our boundaries for the integral going to be? 0 to 1. For both of them?
Yes.
How do you know?
well, it's just roots.
Right. Right. They're both bounded by those vertical lines. Yep. Now, there's a couple ways we can approach this. We can integrate them both separately, evaluate them separately, and then subtract. We could put them together and just integrate from 0 to 1. We could do x squared plus x plus 2. This one's not too bad. This one's pretty straightforward, right? Once we start getting into other where, we're dealing with roots and some other things, sometimes it's easier to keep them separate and integrate separately. But right now, this one's not too hard. So did I integrate correctly? 1/3 x cubed plus 1/2 x squared. Can you see that okay? Okay. So now we want to evaluate with 1 minus 0. Make sure that you are showing that you're plugging 0 in. I know we all know that when we put 0 in for all those x's, it's 0. Still show that, okay? We just want to show that we're evaluating the whole thing. So 1/3 plus 1/2 is 3/6 plus 2/6 is 5/6, right?
Yeah.
Plus 12/6 gives us 17/6. And then, of course, it's area, so I'm going to add in my units squared. How do you feel about that?
Good.
Is it all coming back?
I mean, that comes. I remember it all.
Okay.
It makes sense the way.
Okay. Okay.
Yes.
Could you wait to the slide before this?
Uh-huh.
So I know, like, on the actual.
Yep.
Okay.
I guess the biggest piece that we want to remember is that F has to be the one on top and G has to be the one on bottom. And now notice this one. So A and B are keeping it so that F is on top. But what if we were going over, if I can write, over here somewhere? They would flip. So we'd have to set up 2 separate subtraction integrals. So you'd do F minus G up to this point, and then you'd have to do G minus F for the rest of it. Okay? So it always has to be top minus bottom. And right now, remember, we're sticking with X. We will, I think maybe in 2 days, we'll get to Y, and then remember it's right to left. The rightmost graph minus the leftmost graph. I can't talk today. But we're going to focus just on X for right now. Yeah.
It's fun looking back at the old notebooks that I have.
Uh-huh. Remember when it was so hard and now it's so easy?
It's a hard time.
How's that?
It was great.
Powerful.
That was, yeah.
All right, how about this one? Y equals negative x squared. Y equals x plus 3. Which is top and which is bottom?
Top would be X plus 3.
Why, Zeke?
Because negative X squared is not probably goes inverse to itself. It's so over.
Yeah.
What?
Remember, positive parabolas open up, negative parabolas open down.
Oh.
But it still start at the 0 and it'll be under the x-axis.
It would be.
So the x plus 3 would be on top.
Yes. But we want to check for x equals 1 and x equals 3. So this one's a little different. I wouldn't be checking the y-intercept. I'd be checking at 1. Which one's higher?
Okay.
So if I put 1 in, I get negative 1 and I get 4. Making this G and this F.
So
Would we be given this if they crossed? Would we be given something like this and then have to find where they cross?
Yes, we will. Yeah, we will.
So basically, you're plugging in your X values to find out which is top.
Because we don't really care which one's on top at x equals negative 5. Our interval is only from 1 to 3. So we need to figure out which one's on top there. Now, in this case, the line is going to stay above the parabola the entire time, but the easiest way to do that is to plug in your leftmost point. A lot of times because it's 0, which is nice. So this time we're going to integrate from 1 to 3. And we're going to take x plus 3 minus negative x squared.
Would you'd still combine them?
Mm-hmm. Yeah, this one's pretty easy to do.
So if you have the chance to go, what if
So that's a good question. Like if you're asking me personally, I would say yes, but not everybody thinks that way, and that's okay. If it's easier for you to just integrate them separately and then subtract your answers, go ahead. I personally tend to make fewer mistakes with plugging in when I'm just integrating one function. When I integrate two, I, again, personally, sometimes forget to plug in a number. Because you have to do it twice. You have to do 1 to 3 in the first one, you have to do 1 to 3 in the second one, and then you have to subtract. And I tend to make silly mistakes when I'm doing that. So personally, my choice is to put them together if I can. Again, that's me. You're welcome to do whatever you choose. So the first time AB had a problem like this where they had to evaluate this without a calculator, they freaked out. How are we supposed to do that math? You need a calculator. Nope. It's expected that you can do all this in your head. $132 over 6. Nope. Need to reduce that. $45 plus 11. 56 over 3.
Yeah.
Okay. So I multiplied 15 by 6, and then I realized no, 22 and 6 is reducible, so I probably want to go that route. Yeah.
Wait, is it negative?
No.
It's the same number but different.
Did you do 1 minus 3? It's the only thing I can think of is if you put it in backwards. Okay.
3.
So you plug in all the 3s, and then you subtract when you plug in all the 1s.
Yeah,
You did it vice versa?
I did it
Gotcha.
both times.
That's a common mistake, to plug the bottom one in first and then the top one. Remember that it's the top one minus the bottom one. Or rightmost value minus leftmost value, whatever. Naz, do you agree with me? 56 thirds? Did you do it the same way I did, or did you do it differently? Okay. I mean, you guys know I'm never one to tell you, like, you have to do it my way. You don't have to. Just whatever makes sense for you is fine.
Usually your way is most efficient.
I try to be. Doesn't always mean it's the best way. All right, are we okay with this, and are we okay doing it without a graph?
Yeah.
That's the big piece. When we did this last year, we always looked at the graph. But you're not always going to be given a graph, so I want to make sure we can do it without.
As long as you
Make no promises.
I don't like the next
So far,
If I did the next
so far
slide,
it's not so bad.
next
Okay.
slide could be like, here we go.
Well, the next slide is what happens when they intersect. And you're just told to find, you're going to be told to find the area of the bounded region.
Oh, you have to.
And we're not given the interval, so we're going to have to find the points of intersection. So notice this one just says find the area of the region. It doesn't say from, 1 to 3 or 2 to 5 or whatever. So what we have to figure out is where our points are. Now it looks like it's -2 and 1, but we don't ever want to make assumptions, right? Right?
Yes, right.
So we need to find the points of intersection for y equals x and y equals 2 minus x squared. How do we do that? This goes way, way back.
I probably know that.
The easiest thing here would be to simply substitute. Substitute x in, right? So x equals 2 minus x squared. Do you remember systems from Algebra 2? Your choices were substitution and elimination.
Yes.
But anytime we get past linear, substitution is generally your best option. Is it ringing like a real, like,
See, like, I
bell?
I remember the words.
okay?
Yeah, but I don't
Okay.
know.
No.
So here's my tip here. And this one works out really nicely. I can't promise it always will. But we need to find with respect to x, right? So if we can substitute to get the x values, we don't actually have to solve for the points of intersection. We just need to solve for the x values of the intersection. So substituting in where I have y's in the equation takes me extra time. This one is set up real nicely where I can get rid of the y's and just deal with the x's. So we're going to have x squared plus x minus 2.
Oh,
There we go.
The bell has rung.
Yes. So our assumption based on the graph is actually correct. It's at -2 and 1.
Wait, so,
Wait, no, isn't it? Wait, what?
so you said y equals x.
Okay, so those are our functions, right? The first function is y equals x. That's the linear one. That's the g, sorry. And the f is 2 minus x squared.
Yes.
But when I'm solving a system, I use y instead so that they're the same, right? And then this one is set up real nice. If I know y equals x, I can just put x in for y. I can substitute
Oh, I see.
into the second equation and then solve. Is that a, oh, I get it, or like a, oh, I don't remember this?
I don't remember it.
Okay.
That makes sense.
Okay. Yeah, this was what, 3 years ago?
Yeah, I don't think I've been taught this. I remember. I think I remember.
Okay.
I got there without looking at this. I'm learning.
So I'm making a mental note right now that I probably need to include more of these in pre-calc when I do this. Okay. We did systems in pre-calc. We did 3 variables, and we did a couple of conics, but
I
not
never learned the application.
not much. Yeah.
We knew like we did.
Yeah. No, we did all those word
I don't remember
problems.
that. I remember the problem.
Good.
I remember like 3 lines of like stuff you had to go figure out.
Uh-huh. It was annoying. All right, so now we're ready to integrate from -2 to 1. And this one's kind of nice because we can see that f is above g. So we know we need to take 2 minus x squared minus x. And that's what we're going to integrate. Okay, so let me pause for a second. Everybody with me on where the -2 and the 1 came from? Okay, so usually when we were solving systems, we were trying to find the points of intersection, right? But all we really care about here is x. So once we find x, we're good. That gives us our interval, the -2 to 1 for our interval for our integral. And then we're taking top minus bottom again. The top is the parabola, and the bottom is the x. So now we're just going to integrate. And we're going to evaluate from -2 to 1. Half of 4 is 2. There we go. -1/3 minus -9/3 is Does 4.5 sound right? Sorry, check. Continue. Then you can check me. I think I kept all my signs right. You know what I enjoy is that we're sitting here doing this problem. It's a fairly complicated calculus problem. Nobody's touched a calculator yet. This is all in your head.
I was talking to a freshman. I was talking to it's Ty, who's in algebra
Uh-huh.
2.
Yep.
And I was like, yeah, oh, you're in algebra 2? Awesome. You should take the calculus. You should totally take it. It's like, so like, what do you do with calculus? So like, calculus is just calculator. You just
Yep.
calculate things,
Yep.
right?
Yep.
And I was like,
Yes.
I remember
Yes,
the day,
that's
and I thought
exactly
that
it.
too. I remember the day. I was like, I don't remember the last time I touched a calculator.
Yep.
On this class.
Yep.
It's almost like a sin to touch calculator.
It is, but isn't it amazing what your mind can accomplish?
You might probably have answers today.
With a piece of paper.
Yeah. I mean,
Necessary.
seriously though, that it's pretty amazing when you think about it. Do we agree? Are we in agreement or no?
Fair enough.
Okay.
Well, why would you use decimals, Miss Collins?
I know.
Yeah, that's right.
I know. Sorry.
Well, wait, isn't so the -2 minus 4?
4.5 is 9 halves.
Is -6, but plus 6 would be 8, right? And then you have 1/3 minus 1/2 is -5, 6, right? Then you have 8/3, so it'd be like 2 minus 5, 6 plus 6 plus 8/3.
Secret, I lost you. Wait, what did you do?
So -1/3 minus 8/3 is -9/3, which is -3. So that's where that came from. I put them together because they have a common
Oh,
denominator.
that's smart. I see how you did that.
And then 2 plus 4 plus 2 is 8, right?
Oh, I had.
And then I have -1/2.
I see how you did that. I like that better than the way I did
But isn't it?
Did you get a common denominator for everything?
Isn't it
Yeah.
-8/3 though?
I'm sorry, say that again?
Isn't it -8/3? Not plus 8/3.
No, because when you cube -2, it's -8 times -1/3 is plus 8/3. So it should be plus 8/3 in the parentheses.
Oh.
So your sign was off. That's why.
Yeah.
Okay.
That makes more sense.
Hey, you're defensive. For some reason, instead of using -2, I used 4, so I put -4 for the first one.
Oh
So
no.
I was like, why is it 8? And
No.
I'm like, oh wait, it's 2.
Mine over 2, not 4.
So I had 64/3.
Oh,
It's like,
yuck.
that's not
Okay, sorry, 9/2. There you go. I was being lazy. You did?
We have arguments with Mr. Marsh about that.
About what?
Decimals.
Oh, versus
We haven't
fractions?
talked about this.
I'm okay with 4.5.
That's okay.
But like
What
anything
did you-
else,
what did you
no.
say? What was it? Was it 0.67?
Yeah, that's not a real number.
0.67.
Ever.
Like, oh, Mr. Marsh.
That's still an approximation.
But then we were doing a part of it has reciprocals, and we're like, are those fractions? Mr. Marsh, she's like, she's so anti-fraction.
Uh-huh.
Like, I see some fractions on the board.
See, and that's the part I've never understood about scientists. Why would you go like 0.66667 when you could just do 2/3?
He had it in a fraction. He had 0.666, like, as honestly, you could just.
But why? Like it would be so much easier
And
to use a
it, like, 'cause
fraction
it gave us, for
and
us,
more
it was
exact.
When you divide something and then cross multiply, and you got a nice even, nice number.
Right.
Him, he had all crazy decimals.
Yeah.
And then he added them all together, and he got 60.3.
Right.
Instead of 60.
And so like you guys were exact and he was off.
So then he did squiggly line equals.
I don't care.
You're like, no.
But I feel like in engineering, if you're measuring something, 60 is very different than 60.3, you know?
Yeah.
Whatever. Scientists be crazy.
Oh, yeah.
Okay. The sine and cosine curves intersect infinitely many times, bounding regions of equal areas.
Oh,
Think about that statement.
that's
So every time they intersect, like this region is equal to this region, congruent, right?
I heard that one
Yeah.
a long time. That was
You were doing it
that took me back.
Yeah.
That
Yep.
one took me back.
Ruin.
Congruent.
Congruent is used for like shapes, right? because they're not technically equal because they're not technically the same shape.
But they're
You know, they're two shapes of same size.
That's weird.
well,
Anyways, let's pretend that didn't happen. How do we find the area of one of these regions?
Yeah, how do we find it?
well,
Intersection. You have to find the x value.
So we have to, yes, we have to find the x values.
isn't each region different though? Because isn't one sine on top one time and cosine on top the other time?
Yes, but the regions will have equal area.
Right. Yeah.
So yes, it depends on, like if we were going to do the second region, we would have to put cosine on top.
Is it not going to be 0?
Is it not going to be 0? Oh, you're saying that there's equal area above as there is below.
Yeah.
Let's find out. Too bad, so sad. Zeke, we'll let you pick the region. Do you want to use the pinkish region or do you want to use the white region?
You know, that's these right quite superior.
That's recorded.
That is
recorded.
I didn't say why it was.
Alex, you heard that?
I didn't say why it was or what reference
What do you
it
mean I didn't say why?
I just said the color- I said the
white
color.
supremacy.
was. I said the color white is superior.
Actually, you didn't. You did not specify color white. You just said white. He's feeling bad about himself because of that last one where he messed up the negative. He's got to reassert his dominance.
I'm just kidding.
It doesn't matter. It just the only difference is whether sine is on top or bottom, right? Okay, so we'll make sine f then, and we'll make cosine g.
How do we know the boundaries?
That's what we have to figure out. So how do we figure out where they cross?
Oh, wow, look at that.
Yep, and then you set them equal to each other.
That would be on a tangent. No, not on a tangent, sorry. On a over 4. Right?
Like a pi over 4?
Pi over 4.
Yes. Okay, yes.
It'd be-
Actually, it's funny that you said tangent. So the book solved this differently than I would have. I would have just looked at this. I know where cosine and sine are equal to each other, and that's at pi over 4. They divided by cosine.
Is it really?
Yep. Which is tangent, and said, where is tangent equal to 1?
That's cool.
Oops, I forgot my x, sorry. See, I found this very interesting because my mind immediately at cosine equals sine, I already know that's pi over 4, but I need a second value. That's where tangent is helpful because where is tangent equal to 1?
That's so cool.
Well, it's in the first region where tangent is positive, right? Which is, or first quadrant, pi over 4. Which other quadrant is tangent positive in?
The third.
The third one. And what's the pi over 4 value in the third one? It's bigger than 1.
5.
Correct. So at this point, which is where I would have solved, is pi over 4, but then I have to really think about where is the other one where they're both the same sign. Tangent makes that easier.
That's so cool.
So this, yeah, I thought it was kind of a cool way to do that. Again, either approach is fine, but tangent makes it a little easier to see the two values. So we're going to integrate from pi over 4 to 5 pi over 4. Are we going to do sine minus cosine or cosine minus sine?
Sine minus just. Yeah, how would you, because then if we just did that, how would we know that it's sine or cosine? Other than knowing the graph.
Well, I would hope you would be able to picture it in your head
Right.
and know that.
That's it.
That's really the only way that I can think of. Now, if we were doing the white region,
Right.
it would be cosine over
And
sine.
we'd have different
Values.
Students and staff, pardon this interruption. Sophomores, you will report to second period Teachers, please take their attendance
that's
and then
right.
immediately send the
Forgot about
sophomores down to the auditorium. They do not have to have their possessions on them. They can bring them with. They will then be reported directly
He
to
always
third
says that.
grade.
It's
So maybe bring those. I guess I should bring them with. Bottom line, check into class and then immediately report to the auditorium. The bell just went off. Thank you.
so we've got negative cosine minus sine, right?
I didn't hear the bell, so
Okay.
we should stay in here.
Well, we can finish this one real quick.
Test.
Yes, we heard you.
Test.
Oh no.
Is that gonna be there?
I can't finish the equation.
Oh.
All right, I'm gonna throw one at you. You ready? We can still hear you.
Turn it on.
That could have gotten bad real fast.
They could have got real bad with that.
Oh, that's funny. All right, cosine in the third quadrant is positive or negative?
Negative.
Okay.
Test.
It is still on.
Oh, don't worry.
And sine is also negative, right?
Yeah.
And then in the first quadrant, they're both positive. So 4 over square root of 2?
Yeah.
Because they all end up being positive, 1 over square root of 2, yes? Okay.
Test.